Okay, so today we're going to learn how to solve radical equations. Before we do so, let's learn some tools on how to simplify radical expressions.
Okay, so when simplifying radical expressions, although these terms are not perfect squares, you can still further simplify them. What you do is you take any factor that is a perfect square and remove it from the radical. And as you do this, you also take the square root of that factor. So for example, 72, we know two factors are 36 and 2, and the square root of 36 is 6. So what you do is you take out 6 and leave the other factor inside the radical. Alright, then moving on to number 2, it is the square root of 125, and 25 and 5 are the two factors, and so when you take the square root of 25, you get 5. And then since there's also a variable in this equation, we know 2 goes into 4 twice, so therefore the variable is just going to be x squared. So your final answer is 5x squared radical 5. Okay, finally for number 3, since it's now a cube root rather than a square root, and it's only variables, you simply see how many times 3 goes into each exponent for the variable. So for the first variable, 3 goes into 10 3 times, so it's x cubed. 3 goes into 5 once, so it's simply y to the first. And then since 3 doesn't go into 2 at all, you just leave it inside the radical.
Now we're going to discuss the different properties used to simplify radical expressions. The first one is the property of multiplying radical expressions. So when you are multiplying two separate radicals, you can combine them and then multiply the terms inside the radical. Then for the property of dividing radical expressions, when you divide two separate radicals, you can combine them and then divide the terms. Next is the addition property. So when we are adding radicals, we're simply just going to add the coefficients. So for this example, the coefficient is 3, and the coefficient in this one is 4, and the sum of the coefficients is 7. Then the subtraction property is you are going to do the same thing with the coefficients, except you're going to subtract them. So the coefficient in this is 5, the coefficient in this is 3, therefore the difference of those two is 2. Now this next step may be a little bit hard to remember. Rationalizing the denominator. So if we have an instance of a fraction with a radical in the denominator, we have to multiply it out. So this is what we're going to do. We're going to multiply by radical 2 over radical 2. Then these denominators will cancel out, leaving us with just 2, and then we just further multiply these two. Now number 2 is a little different because not only do we have a number, but we also have a radical. So what we're going to do is negate this and then multiply it. So we're going to do 6 minus radical 3 over 6 minus radical 3. Then when we simplify that, we get 24y minus 4y radical 3 over 33, which is what we get after we FOIL these two values. Just as there are properties for radical expressions, there are also properties for rational exponents. Now here's an example where we apply some of these properties. So first we have a squared, b to the 1/4, and t all to the negative second power. So first what we're going to do is distribute the negative 2. So we have a to the negative 4th, b to the negative 2/4, which is also equal to b to the negative 1/2, and t to the negative 2. Now since we know based on our property, since this is a negative exponent, we're going to move all these terms to the denominator. So we'll do 1 over a to the 4th, b to the 1/2, and t to the 2nd. Now, however, there's a problem in this answer because we have b to the 1/2. You are not allowed to have rational exponents in the denominator. So what we're going to do is we're going to multiply by b, whatever's missing, to make this a whole number. So 1/2, and we have to do that to the top as well. So we're going to get b 1/2 equals a to the 4th, b, and t to the 2nd.
Wait, radical expressions and rational exponents go hand in hand?
Yes, in fact they do. Rewriting rational exponents as radical expressions and vice versa. So let's take a look at this example here. We have a to the rational exponent 1 over n. The denominator, which in this case is n, is the value of the root, while the numerator, which in this case is 1, is the exponent of the term in the root. Here are some examples of common rational exponents and complex examples. in most cases, to square both sides of the equation. However, this depends on the value of the radical. For example, if we have a cube root, you're going to have to cube both sides, and so forth. The next step is once the radical is removed, you're going to solve for the variable. And then the last step is to check all answers for extraneous solutions. Now let's try some examples of solving radical equations. In our first example, to isolate the radical, we're going to add 3 to both sides. Next, we're going to square both sides of the equation to eliminate the radical completely. Then, we're going to solve it like a regular equation, and after checking for extraneous solutions, we get x equals 28. Now, our next one is a little more complex. To isolate the radical, we're going to subtract x from both sides. Then, we're going to square both sides, and after squaring this binomial, this is what you get. Then, we're going to move all our terms to one side, and that'll allow us to factor. And that gets us 2 answers equaling x is -4 and -6, and neither of those answers are extraneous. Now, let's try a more challenging problem. Okay, so here's our equation. So now, just looking at this, we cannot simplify any further. So we're going to have to go to our second step of squaring both sides. Now for this side, we're going to have to FOIL. So when you FOIL, you get the answer of minus t. Then for this side, since it's a square root and a square, they both cancel out, leaving us with 4 minus t. Now we're going to have to move all our variables to get them to one side. So we're going to add by t, which eliminates the t on this side and this side. Then next, we're going to subtract 6 from both sides. So we have -2 radical 5 minus t equals -2. Next, we're going to divide by -2 on both sides. That leaves us with radical 5 minus t equals 1. Now we're going to move over here. So now we're going to square both sides. So we do 5 minus t, because by squaring this, we're eliminating the square root, and by squaring 1, we get 1. So now we're going to subtract by 5 on both sides, which gets -t equals -4, and then once we divide by -1, we're going to get t equals 4 as our answer. And after we check for extraneous, that answer is correct. Fantastic! Just like Patrick, we're all excited now that we know how to solve radical equations.